to talk about writing software that takes advantage of immutable data, even when you're using Perl, which is not really what people would describe as an immutability-friendly programming language. So, the first thing I want to look at is simply what immutability means. And the central idea, which might sound a little ridiculous at first if you've not encountered it before, is that variables don't actually vary. Instead, every variable has to be initialized to some value when you create it, and then it retains that value forever. And there are some languages where everything behaves that way. Best known these days is probably Haskell. Another really interesting one is Idris. Just as a side note, Idris was designed by Edwin Brady, who also designed the whitespace programming language. And he's also an occasional Perl monger, so he's definitely a good person. These days, these languages tend to come out of academic computer science research, and that's certainly true of both Haskell and Idris. So what would immutability look like in Perl? At the most basic level, this is the sort of thing I mean. So you can create a scalar like $i with an integer. You can create an array, in this case @roots, which contains the square roots of another list of numbers. You can have a hash like %spouse. But you can't change $i in place. You can't push anything onto the end of an existing array. You can't add elements to %spouse, overwrite anything in there, anything like that. So that's kind of the really short version of the what. But you may be sitting there with another question. Why would anyone actually want this? And one important advantage is that certain sorts of reasoning about program behavior, thinking about what your program is actually doing, become much easier, especially in the face of things like structure sharing. You've got some hash ref that you pass into this routine, and knowing that that routine isn't going to change it can be quite helpful. Whenever you know that some variable name always refers to the same value, that gives you a lot more ability to think about what's going on with confidence. It's also the case that even if you've been unwise enough to design your system to use shared memory multi-threading, data races are impossible because, well, everything is just, you create it once and it never changes, so hey, all that stuff goes away. The flip side of that analysis is that rather than immutability being a good thing, maybe you should think of mutability, the ability to change your data, as being a bad thing. And there is, I think, a sense in which that's true, but I think looking at the world just in that way has real problems. I prefer to think of the problem as being shared mutable data, rather than just mutable data per se. So what do I mean by that? Well, here's a perfectly cromulent bit of Perl code. I'm sure lots of people in this room have written code like this any number of times. So you can see they've got two separate variables that get mutated, both highlighted here. And I honestly don't find this much of a problem. The mutable variables here, they're only used within this single lexical scope, this single routine, realistically, and they're not shared with any other part of any wider part of a code base. And rewriting this code to dogmatically avoid all mutable data wouldn't, I think, actually make it any easier to express, or importantly, to understand. But immutability does start getting more important, more useful, once a piece of data is shared across wider boundaries. And the bigger the radius of sharing, the bigger the pain. So in particular, where do we store a lot of our data? We store it in databases. And if you've got some database that can be accessed from any part of some million-line code base without restriction, well, that might turn out to have some problems in the long run. And this suggests a route for making good use of mutability where it is actually helpful, without abandoning everything you know about the advantages of mutability, and without abandoning the familiar approaches of Perl and all the CPAN modules that we know and love. So that's kind of the background of where I'm coming from. And I'm going to talk about the piece of software I promised to talk about, what this means for my company, Cutbot. So we started in 2009 doing just online media monitoring. So this kind of, think Google News Alerts, but more powerful, more flexible, more features for people who work in public relations, that sort of thing. So for example, we let you restrict search terms to publications in particular geographies, to just national newspapers, to the right sort of trade newspapers, and rather than sending an email whenever we find a match, we batch them up and we send them out as nicely formatted briefings, and it's all great. But the bit I'm talking about today is our public affairs monitoring product, which launched in 2012. So where the media product tracks news articles, the public affairs product tracks the activities of public bodies. That's parliaments, assemblies, governments at all levels, all the way down to selected local councils, or at least that's the plan. So we started with the Scottish Parliament and Scottish Government. We're in Scotland, we have a certain amount of familiarity with what these bodies do. They're also relatively small, good places to start, and they're not really target markets for most of our competitors, so that's nice. We're currently putting the finishing touches to Westminster, and I've been saying that for some terrifyingly long period of time. Next after that is probably Whitehall, then maybe the Highlands and Islands Council. Sounds a bit weird, but there's lots of useful planning-related stuff happens there. We might do Northern Ireland, we might do Welsh Assembly, we might do some of the EU bodies. We've got lots of options. We do have some pretty big differences between the needs of the media product and the needs of the public affairs product. So for media, one of the issues that matters to our customers is whether we cover all the relevant outlets, whether that's the national and local newspapers of the place they're in, whether it's all the trade publications that their customers read, all of that sort of thing. So that means we kind of always have an incentive to cover more publications, even at the expense of some precision in how well we can manage to ignore the navigation elements of every web page and just extract the crucial body text. So, we've got something like 10,000 publications from around the world and 2 people on staff, and we just can't, therefore, manually say, oh yeah, well, this publication means it's this bit of the page that's going to be important. And that's especially true, you start thinking with 10,000 publications, there's always at least one of them that's changing its markup. So we that would not work. But with public affairs, increasing coverage means something slightly different. It means finding more information from a single body rather than necessarily adding more bodies that we cover. And because we're competing more directly with companies that sell human analysis of political issues, it's all the more important that we have to extract every last bit of useful information that we can, and then find good ways to display it to our customers. And since we don't provide any analysis of what's going on, we have to make sure that customers can see everything they need to when they want to come to their own conclusions. So even getting all the text of a parliamentary web page isn't actually enough. We have to be able to dig down and find who's saying what and what the context for that is. So here's an example. So this is an extract from a briefing that we sent out a couple of months ago that we generated for a client with an interest in land reform. So the first item is a quick mention from the transcript of a committee meeting, the search term highlighted in context. We have a couple of committee papers that were published as PDFs. It can be really quite annoying to extract text accurately from PDFs, so we just show which search term matches. But we also have the trail of breadcrumbs to the individual PDF, which often provides useful information. So you see we've got this John Muir Trust supplementary evidence, and we say it came from here, this committee page, and this inquiry within that committee, and so on. And the item at the bottom is from a chamber debate at Holyrood. And I think it's a pretty good example of what we can do to present parliamentary information for our customers. So we found several relevant speeches in that debate. We carefully highlight the customer's matching search term within an excerpt from the whole speech, naming the MSP who said it. And we also note that another MSP made a speech that matched the search term as well. And you can't quite tell from this, the lines saying things like speech by Ken McIntosh are direct links to the specific speech in question. And when we started doing this, that wasn't actually a feature that the Holyrood website provided. We were the only people in the world who could do this. And then they added it for everyone. It's a little disappointing. So that's kind of the background for what we're trying to do. Which brings me to the actual software that takes care of this. And this is the 10,000-foot view of how the system works. We have a few dozen crawler processes that download the HTML pages, the PDFs, and so on. Each crawler process takes the next queued URL to download, fetches it, saves it locally, and announces it in another queue. So we have a smaller number of sifter processes that take work items from that queue, and a sifter looks at the data that was downloaded, takes appropriate action based on what sort of page it was, and what it actually contains. So if the thing we looked at was, for example, an index of debates in the chamber, it looks for any that we haven't seen before, creates new downloads for each one, and then gets queues them up for the crawler to fetch them. Or maybe the page was a description of some research briefing, so we'll need to go off and download the PDF of the briefing itself, and then later tie that PDF together with the description that we're looking at on this page, and again, that will be done by the sifter. And of course, in some cases, sifting a page or a collection of pages produces one or more actual items that could be presented as is to the customer. So those then get queued to be worked on by the scanner, which takes the structured data that the sifter found and compares it against every search term that every customer has created. And each matching item gets added to all the appropriate clients' briefings with enough information to do the actual formatting when briefings finally get displayed or emailed. And the crawler here, of course, can be fairly generic. It's just download URL, retry a few times if there's a failure, check that the results content type is what you expect, that sort of thing. But the sifter and the scanner, because they're dealing with this structured data, they need to have custom handling for each of the various types of page and item. And the sifter's the bit I'm going to focus on, because it's where most of the complication is. Last time I checked, it was about 1/10 of the entire code base, just for some idea of the scale. So I mentioned that we have a lot of concurrent crawler processes, and of course that's really straightforward because they're doing something embarrassing in parallel. And we don't have anywhere near as many sifter processes, but we still need to do quite a lot of sifting in parallel. So I think at the moment we're on 8 concurrent sifters handling both media and public affairs put together. And one of the bits I glossed over earlier was that we have to repeatedly crawl the same pages to find new stuff and find only the links that we haven't previously seen. So we have some state, some set of data, which is the set of URLs that we've previously seen. And that set of URLs has to be shared between these multiple concurrent processes, and it can be mutated by any of them as they encounter new URLs. Uh-oh. So it's all very well, I talked earlier about how great life is when you don't have a shared mutable state, where you can just say, oh yes, I always know what this refers to. But well, sometimes you just can't avoid it. This is one of the crucial aspects of the system. We have to keep track of what URLs we've seen. So it's the big tension in the design of the software. I want the sifting processes to treat their shared data as immutable, because that makes it trivial to scale them horizontally. I can add more processes, I can add more machines, I can keep doing that for quite a long time before it turns into a problem. But they do nonetheless need to be able to store data that will be examined by other processes. So how does the software actually make this work? Well, I took a conceptual clue from the way input and output work in Haskell. So the idea is that the individual per-page type sifters never actually modify any of the data. Done. Fine, no problem. Instead, each one does its work, and rather than modifying the data directly, it tells its caller what changes it would like to be made to the data. So this is a very, very rough, very cut-down version of what that caller looks like. So we call the appropriate per-type sifter, that's this sift routine. We store its result in this hash %got, and then we use a nice conventional relational database to store all the data. And the rule is that the per-type sifters are allowed to read the database, they're never allowed to write to it. So in particular, they're allowed to look up which URLs have already been seen, so they can avoid trying to create downloads for them. And then, instead of writing, well, they pass it back to this code. So what happens in this code? Well, we start a database transaction. So we've got the txn do method on the database. So dbx class database schema. The same sort of thing would apply if we used a different way of accessing a database. TXNDo takes a code ref as an argument. It executes that code in a fresh transaction. If anything throws an exception, then the transaction gets rolled back and the exception gets rethrown. But if the function completes successfully, then the transaction gets committed. So how does that help? Well, this transactional function pulls out the sifter's various results from the hash, so the downloads, items, and scenes. Conveniently, there's nothing in practice that can go wrong for the downloads and the items. If it did, that would be a bug. The tricky bit is this set of newly seen URLs. So let's look at the definition of the database table that stores the relevant data. Now, it's not quite as simple as just recording every URL. We break down the set of URLs both by the parliamentary body on whose behalf we found that URL and by the purpose we expect to put that URL to. So we can kind of have URLs that get reused for different things and the scopes don't interfere with each other. So that's the thing ID and the scope columns. And if you're wondering why it's called a thing, that's the Old Norse word for a lawmaking assembly, which sort of seemed like a suitably generic word for me. So then those two columns plus the URL, they make up the primary key in the table. So if we try to insert a triple that's an exact match for one that already exists, then the database is going to give us an error and the insert won't happen. And we know that that is something that can happen. The sifter was permitted to read the database to find out which URLs had already been downloaded while it was working on some particular page. But that means that there's a big, obvious time of check to time of use race condition there between determining that a given URL is fresh and actually trying to insert it into the table to mark it as not fresh in future. Another sifter process could come along and could have inserted the exact same thing, and then we'd get an insertion conflict from the database. But of course, that's exactly what we want. When the database driver sees that error, it's going to throw an exception. So the txnddo method will roll back the transaction, and it's as if nothing happened. So what happens next? Well, we might have some specific error recovery code kick in at that point, trying to work out exactly what went wrong and fix stuff. There's actually a much simpler approach, and this is an approach I stole from Erlang. So the exception gets rethrown, and of course the default consequence is that the entire program just exits with an error message. Fine. And it is fine because the sifter process is, like all the worker processes I've got, we need to make sure that they might crash for any arbitrary reason. So we need to make sure that they always get restarted, that we can recover from a crash regardless of anything else. And there are several parts to that. So first we have a watchdog process that knows which workers should be running, and if it sees that any of them have died, it just restarts them. Whenever a worker starts up, it looks to see whether it crashed last time, leaving an incomplete work unit. And if it finds one, it deals with that before looking for a new item in the queue. There's just one tiny little wrinkle. If the watchdog notices that a particular worker has tried several times to process a given work unit, and it keeps not managing to do it, then it assumes that there's a bug somewhere. So it marks the work unit as needing administrative attention. It emails me, and it restarts the worker to move straight on to a different work unit. And that sounds a little complicated, but it's the right approach anyway, regardless of anything else, given that I need this system to just keep on trucking regardless of anything else, even in the face of bugs. This is the right thing. So going back to insertion conflicts, how does this help? So we've got to the point where we've sifted some particular download, produced a set of newly seen URLs, used the database transaction to insert everything that was found while we were sifting, including the newly seen URLs, and if that works, we're golden, otherwise it will crash and we'll get restarted, and then we try again. But crucially, there's likely to be a delay of at least a couple of seconds between the detection of the conflict and the next attempt to sift this particular download. So whatever conflicting data we encountered will almost certainly have been actually committed when we start up again. So yeah, this time sifting the download will produce actually different data, and we'll no longer treat the conflicting URL as previously unseen, and everything will work. So what are the benefits of this approach over just having the sifter speak to the database directly? Well, I think this is the important one. That it gives me a really good story for how to run multiple sifter processes concurrently while still using this shared mutable state. They can't interfere with each other, it just works. The other really important benefit is that it promotes testing. So I rely quite heavily on two forms of testing for these sifters. One is regression testing. So I've collected sample downloads for all the various page types I need to sift. I've constructed the set of downloads and items and newly seen URLs that should be found when sifting each of them. And that means that later on, it's a huge amount of horrible, painful screen scraping code. And there's always some new, fresh hell of broken markup that the Parliament has just invented. So I have to turn up and tweak the sifters. It's like, oh yeah, I didn't work out how to mishandle this date format where, oh, you missed off the 2 on the beginning of the year. Oh, but I now have to handle that. But I can do this, and I can have a high degree of confidence that my change that I'm doing for this new thing hasn't just broken everything else. And pleasingly, the regression testing driver code is only about 100 lines or so, which is probably less than half the size of the real sifter driver, which of course is a lot more complicated than the dozen-line version I showed here. The second form of testing I rely on is rather newer, but I think it's actually going to be even more helpful in future. So this is a third sifter driver. I can set it loose on a given URL, and it runs off and downloads everything it can find, starting from there, chasing down all the links it would need to follow, and caches all that stuff in a local corpus without ever updating the database. And again, because the sifter never actually writes stuff to the database, this is really easy. I've got a really great place for writing this corpus-generated data that won't interfere with even a testing database, let alone a live database. And of course, the hardest thing about writing these sifters, these screen scrapers, is actually trying to reverse engineer what sort of data a given page might be expected to contain. That is, working out how they should behave. So being able to prime a corpus with, for example, a few years worth of Hansard data and repeatedly run an in-development sifter on it, that lets me evaluate hypotheses about the sorts of HTML that these things can contain, and therefore valid ways to process them, which gives me, again, a high degree of confidence that the sifter behaves the way I want. And of course, I should point out that I've got this huge debt of gratitude to default immutable languages like Haskell. I know I kind of half like Haskell, but I much more like the fact that it exists, and it's got this design that I was able to steal for my own purposes, that I actually like using it for real stuff. And I would say that my experience of building and extending this system makes me think that immutability can probably be best seen as an approach to designing systems, rather than something you should necessarily bake into your language. So, suppose I'd written this software in a default immutable language, a language like Haskell rather than a language like Perl. No one could reasonably describe Perl as discouraging mutable data. I honestly don't think that there'd be any compelling objective advantage to using a default immutable language for this system. I mean, some people's tastes lean much more towards that sort of language, but hey, that doesn't apply to me. It's not therefore actually important to me. I think one criticism of this arrangement might be that there's nothing preventing a badly written sifter from updating the database directly rather than generating a set of updates that it wants its caller to apply. And that is true, but it's not actually a problem for me. I am the only person working on this codebase, and I don't find myself tempted to do that. Now, in a slightly different team, if it was an issue, well, I'd have other options. One option would be to mitigate the risk by concealing the database reads. So, for example, rather than having the sifters be given a database handle which they're allowed to use directly for reads, they could get an individual closure that does the "has this URL been seen" check without exposing the database handle directly. And that still wouldn't offer the same sort of guarantee you'd get by encoding the ability to access the database using the type system. but that doesn't seem like a practical problem to me. And furthermore, I think it's worth bearing in mind that for this system, I do get some other really helpful contingent advantages for avoiding a default immutable language. And one is just that, hey, everything else is written in Perl. So I'd have a real cost for certain sorts of component that plug into my Sifter infrastructure, there'd be a real cost to trying to write one of these in any different language rather than keeping it part of the same system. I do, of course, have a couple of small components written in other languages because, well, I'm not dogmatic about using Perl where it's not the right job. But, you know, I've already found this problem of not being able to reuse other parts of the system a problem for those components that are written in other languages. And I don't want to exacerbate that issue. So I think the conclusion I'd like to draw most strongly is the idea that immutability is most usefully seen as a property of software designs rather than languages. So the overwhelming majority of the world's software, I feel pretty confident in saying, is written in languages that default to mutability. So this system is in Perl. I think most people in this room probably write a lot of Perl. But the same is true of Python, of JavaScript, C, C++, Java, you name it. And I think the great thing about academic research into programming languages has been that people come up with great ideas that have kind of gradually filtered into mainstream languages. So one of the classic examples of this is automatic memory management, or garbage collection. It's clearly the right choice for huge amounts of software that the world needs. And it's been around literally since the first high-level languages. It was in Lisp in 1957. But it's a thing that only took off in the mainstream when it was adopted by Java, which was, of course, a language that was really deliberately seeking to be a mainstream language, a language that would be used for huge amounts of software. And I think there's a growing undercurrent of acceptance among users of mainstream default mutable languages that immutable data is a good tool for constructing real software systems. I think this is a good message for people like me, and I think all of you, that we needn't give up on Perl and CPAN and the entire ecosystem that we're familiar with, or learn something that's new and at the very least perceived as being quite difficult, just to get the huge benefits that immutability offers. So, thank you. So I realise this is a little short, so are there any questions or comments?
Yeah.
Go.
With your Sifter workers, scraping these URLs, did you consider using maybe a pub/sub queue, so your Sifters push their updates of this data they retrieve onto this queue, and then you have a worker that subscribes to a queue and maintains a state of what has been called?
So the question is, did I consider using a pub/sub system? The queue I'm using I use Redis for the queuing. You could look at it as being pub/sub. There are effectively lots of workers that look at the contents of the queue, and adding something to the queue is publishing to that queue. I'm not using Redis pub/sub because Redis pub/sub can lose updates if there's nothing watching at the right time.
Maybe I misunderstood. I thought you meant that your Sifters talk directly to the database.
They read. So I use Redis for the queue, and I use a SQL database for storing the data that they found. So the Sifters are allowed to read the contents of the SQL database. They don't actually, again, the communication with Redis is done by telling the caller to write to Redis. We don't actually speak to the Redis database directly at all. Yes?
So why is it that you're having insertion conflicts between Sifters? It seems like if you're using Redis, that the queue is atomic, and if you're using it properly, then, well, I assume anyway, that you would basically only have problems if you're crawling links across Sifters that end up pointing to the same sub-content.
So yeah, the Redis is a side issue here. It's insertion conflicts in the database, and yes, we can find that we've approached the same fresh link by two different routes. So we had Sifter A working on this page, Sifter B working on this page. They both found the same URL. That can happen at the same time, and that's where the conflict comes from.
Why not delegate the sub-URLs back into the queue and have, then you could also increase concurrency by having the sifters be able to handle
there are other ways we could structure this. So if we said, okay, the new URL is going to the queue, well, the way it's structured, we have most of the data about the things we want to download lives in the SQL database, and the Redis queue is just a cheap way of announcing that there's a new thing in the queue, in the SQL database that needs to be worked on. So we could restructure things so that the crawler checks at that point to see whether this URL has already been processed. But then we do still need to have some URLs that are repeatedly processed anyway. So it's only for this tracking freshness, which isn't the same as tracking whether we've ever processed this URL before. We repeatedly crawl the same things. Tom?
So you mentioned that you've got multiple sifters, and but only one thing updates the database. So how do the multiple sifters talk to the one thing to get it to update the database?
There are multiple sifter page types, there are multiple sifter processes. Each sifter process can talk to the database, but the ways it talks to the database are highly constrained. It's that the driver speaks to the database, the per page type sifter doesn't. And because I'm confining the database updates to this one piece of code, I can not worry about the complications of screen scraping, of finding the right stuff to do. I can just concentrate on, am I getting the updates correct? Am I correctly handling the insertion conflicts? Hakeem?
You mentioned before about the breadcrumb trail
Yes.
In the briefing. Is that done by tracking what path the crawler took to get to the documents?
Yeah. Basically, we know that we started from this. The Parliament has a page index of committees. We find the committee, we go to their top level page, we track all the pages down there, and yeah, we just keep track of, for each download, we know what the sequence of pages to get to that was.
And because you can get to documents in two different ways, you get a thing where you could conflict on which of the breadcrumb trails you report on.
It could happen, and I decided I didn't care about that.
Okay.
Because one of the things about that breadcrumb stuff is it's context to help humans work out what it is. And it kind of doesn't matter that there might have been, you went from the Rural Affairs, Climate Change and Environment Committee to this particular inquiry they're conducting and then to this PDF, or you went from that to they're working on this bill and then you came to the same PDF. It's still enough context for the customer to be able to read that in the briefing and decide whether they care enough to click on it. Stephen?
Do you think that when Cutbot begins to overtake Google and Facebook and everything?
Yeah, next week.
Do you worry that as you bring more people in, that this sort of precious little thing you constructed will get completely ripped apart? And have you given thought to how to do that, and whether and do you see it as a technical or a human problem?
A bit of both. So in case people didn't hear that, it's like, to what extent is it going to be a problem as we grow, as we take on more staff, that we've got these rules about how to access data that we're encoding in, we're encoding informally rather than baking them into the system. But I think to some extent, I think this can be handled with code review. To some extent, there are other technical solutions we could apply to make it harder to accidentally write data to the database in inappropriate ways. It is a thing I've thought about. I'm not saying I have the one perfect solution. As this happens, as we grow, as we hire more programmers, I will have to think about that. Anybody else? Okay, thank you.